All right, so we're going to use this activity to kind of introduce slope fields. And we did something called Toothpick Tangents a long time ago. And you can get a toothpick in your house if you want to do this. I'm going to actually use a little ruler to do it, to look at the graphs of some differential equations. And they're going to be possible slopes. So anyway, let's look at the differential equation dy over dx equals 2x. What does each dot on this derivative graph represent? And so for a differential equation, it's an equation of slopes. So each dot represents the slope of the line tangent to y at that particular x value. All right. And so what we're going to do, I'm going to get you started and then you guys can do it. We're going to plug each one of these points in to the differential equation and write down what you get. And like what you actually get, what comes out of there is a slope. So for example, for the point -2, 2, we plug it in. We only have an x to plug it into. So it's 2 times -2, which would be -4. All right. Same thing for this one. We plug in the -2, we get -4. So plug in all those x values into the differential equation. Pause the video if you need to. All right, so if you're not done, just pause it and then check yours with mine. All right, so for each of those ordered pairs above, we're going to sketch a mini toothpick, so a little bitty tiny slope line segment at that point with the given slope. And then we're going to fill in some patterns. And so the point -2, 2 is this point right here. So at that point right there, we're going to draw a little tiny line that has a slope of -4. So I'm going to put the corner of it on that. And so a slope of -4 means we're going to go down 4, right 1. So it should be that slope. So we're not going to draw that big of a line. We're just going to draw a teeny tiny line segment that has a slope of -4. All right, then at -2, 0, same thing. All right, and then at -2, -1, same thing. I'm just going to kind of mock it. All right, so all of those in that vertical line have an x of -2. So when we put them in, they're all going to give us -4. So I'm just going to, that whole vertical line should be a slope of -4. I didn't draw that perfectly, but that slope fields aren't perfect. All right, then at -1, 2, I should have a slope of -2. So -1, 2 is this point right here. I should go down to right 1. So just draw a little slope right there. So it's a little less steep than what I had for my -4. All right, same thing at -1, 1. At -1, -2. Oh, I can't really do that. I'm just going to have to mock it. And so all of these should have, in this vertical line, should have a slope of -2. Okay, and then for the next few points, 0, 1, there's a slope of 0. So 0 slope is a horizontal line. 0, -1 has the same slope. 0, 0 has the same slope. So basically, everywhere here on the y-axis, you're going to draw horizontal lines. All right, and then 1, 2, we have a slope of 2. So it's positive 2, so up 2, right 1. All right. 1, 1 was before that one. I missed it. 1, negative 2. Can go up 2, right 1. All right, and then I'm just going to kind of mock that angle. Okay, and then the next row or column, we're all going to have all 4s. So at 2, 1, I have a slope of 4. Let's just double check. So that's up 1, 2, 3. Oh, not quite. 1, 2, 3, 4 over 1. Okay. This one, what I was saying. So just kind of follow along in that same slant. Okay. So that's drawing a slope field. You just take the ordered pair at that point, plug it into your differential equation, and whatever you get, you're going to draw a little baby slope that right there. So like if you get 5, you draw a little baby slope of 5. Right? And then for 4, we're going to sketch a curve that follows these slopes. So I'm just going to put a point right here. And I'm going to sketch a curve through that point. All right, so at that point, it should be kind of flat. And as I go to the right, I'm going to follow the flow of points. I'm going to follow the flow of the slopes. And it kind of looks like that. And the same thing over here. It's going to be flat, and then it's going to follow the slopes, kind of like that. The question is, how many curves are possible? And there's actually infinitely many curves. Because this same curve can be shifted up or down. All right. So for 5, we're going to find the general rule for y based on your knowledge of antiderivatives. Does this support the curve that you drew in question 4? So this is a differential equation. I want to figure out what function has that derivative. I'm going to find the integral of it. All right, so I'm going to add 1 to the exponent and get 2. And then when I divide by my new exponent, I just end up with x squared plus c. All right. And it does match that. I mean, I didn't draw it perfectly, but that does kind of look like a parabola graph. And then the plus c takes into account all the different shifts you can do up or down.